Okay, now let's solve this problem. We have an arithmetic sequence that its fourth term equals 56 and its ninth term equals 111. They ask us to find a1, or the first term, for this sequence, the common difference, and the sum of the 15 first terms. Well, it's easy if we write it this way. We can see that 56 represents the fourth term and 111 represents the ninth term. If we analyze this part of the sequence, we will find out the d, and also we can find the first term. So let's start. To solve this problem, we need to change this one to the first term, and this one first, second, third, fourth, fifth, sixth, the sixth term. If we change it like that, we will have that a6 equals a1 plus n minus 1 times d. We have that a6 equals 111. a1 equals 56 plus n. Again, n equals this little number here. So it's 6 minus 1 times d, but we don't know d. That's why we need to solve for d. How do we answer this? Follow PEMDAS. Is 56 plus 6 minus 1, 5d. How do we solve it for d? We need to pass the 56 to the other side, so 111 minus 56 equals 5d. And 111 minus 56 equals 55. Equals 5d. Now, if I solve it for d, we will have that 55 is divided by 5 and d equals 11. We find our first answer. D, I will write here, d equals 11. Now, with the difference, we are now able to find the first term. We can choose or a9 or a4. Let's use a4. If we choose a4, we will have our formula like a4 equals a1 plus n minus 1 times d. a4, we have it here, is 56. a1, we don't know, that's what we are searching for or looking for, and equals this little number. So it's 4 minus 1 times d, we already found it. So it's 11 times 11. So it's 56 equals a1 plus 3 times 11. 56 equals a1 plus 3 times 11 is 33. So we need to change or pass the 33 to this side, and we will have the 56 minus 33 equals a1. a1 equals 23. This is our first term. So we already found a1 or a first that equals 23, the common difference that is 11. So we are missing just S15, or the sum of the first 15 terms. Since we don't know the 15th term, we will use the formula when we don't know the last term. So it's n divided by 2 times 2 times the first term plus n minus 1 times d. And we will have is 15. This is our n equals 15. This n equals this one over 2 times 2 times the first term that we already found plus n minus 1, and again we have the n, that this n equals this one, that equals this one. So 15 minus 1 times d, and d was 11, or for this problem is 11. S15 equals 15 divided by 2 times, we need to follow PEMDAS to solve this one. 2 times 23 equals 46 plus 15 minus 1 is 14. I will need to use another parenthesis. 14 times 11 is S15 equals 15 divided by 2. Then is 46 plus 14 times 11 equals 154. I will need to use this part of the page. So it's S15 equals 15 divided by 2 plus, not times, 46 plus 154 equals 200. So I will write it here. Finally, we have that S15 equals 15 divided by 2, 7.5, times 200 equals 1,500. This is our answer. So when we know two terms of the sequence, we need to find first the common difference, then the first term, and finally the addition of the terms they want us to find. Thank you.